Okay, here's another Kmap minimization problem that's a little more complicated just because there's a lot more ones to cover. And so let's start going through that. The first thing we do is make a cardinal map, and we have AB. A is the most significant bit, B is next, then C, D. So we have this function f. It's 4 variables, so we make 16 squares, and we can start numbering that with the pattern we've talked about. Okay, so you can get to that pretty quickly. Here's the A region. B is this overlap with A on that half of the map, and then so those are horizontal, and these are vertical. Here's C, and here's D. And just as an example, let's pick one. Midterm 9. 1, 0, 0, 1, 1, 0, 0, 1 is binary 9. So that's how this labeling goes. It's consistent with binary to decimal. Okay, so we have our midterm list, and let me change the pen colors just so it's obvious where the ones are. All right, so we have a 1 at 0, 1, 2, 4, 7, 8, 9, 10, 13, 14, and 15. Okay, and so once we have that down, all right, so we start looking for essential prime implicants. All right, so one way to do that is to find all the prime implicants and then try to figure out which ones are essential. But you start to be able to pick out patterns, okay? And so look at midterm 0. There's a couple of ways you can cover that. All right, one way is a group of 4 here and here. Okay, and then there's another way where you can cover it where it's right here. So 0 is not involved with a prime implicant. And so, I mean, it is a prime implicant, but it's not an essential prime implicant. Okay, and so we keep looking. All right, so I'm looking at this term for 7. 7, the only adjacent square is 15. All right. There's no other way to cover 7, so that's an essential prime implicant. Okay, then I can look at 2, and I'll go with a different color. Let's go with red. 2. 2 is adjacent to 10, and then we see this big group of 4. That might not be easy to see. Remember, the corners are adjacent. If you visualize folding the map horizontally, the 2 and the 10 would touch the 0 and the 8. If you visualize folding the map, let's see, yeah, fold it vertically, the 2 and the 10 touch the 0 and the 8. Fold it horizontally, the 0 and the 2 touch the 8 and the 10. Okay, there's no other way to cover midterm 2, all right, or for that matter, midterm 8. So this red grouping is an essential prime implicant. Okay, and then I start looking to see what's left. All right, and so I'm thinking, well, I want to cover group 1, and the only way I can cover 1 is with this blue grouping of 4. All right, so that's also an essential prime implicant. All right, and if I'm trying to cover 4, the only way to cover 4 is with, let's do a different color, let's do purple. This is 4. Okay. And then 14, I'm seeing a prime implicant here in pink. Well, actually 14 can be covered in a number of ways, and so can 13. So it's not an essential prime implicant, but it's a prime implicant to cover the rest of the ones. So I can do that with pink, and we'll go with a light green. So at this point, I have all the ones covered, and I don't think I have any redundant groups, all right, because I've looked at covering the essential prime implicants first, and then adding on regular prime implicants. Remember, an essential prime implicant is covering min terms that can't be covered in any other way. All right, so we couldn't drop those out because then it wouldn't cover certain ones. Hopefully that makes sense. You'll get this if you just keep practicing these. Okay, so let's start writing down the logic expression. I'll put this in black. All right, so let's first do the grouping that is blue. All right, so blue, remember our process. Start at the variable A. The blue group spans A. It's in A and both. It's both in A and A bar. So A drops out. It's not in B. So B bar. And then C. It's not in C. It's totally not in C. All right. And then it spans D. So D drops out. Okay, so there we have the blue grouping. Next, we're going to do this purple grouping. All right, and so with the purple grouping, I'm outside of A, so I put down A bar. I span B, so B drops out. I'm outside of C, so C bar. I'm outside of D, D bar. All right. Now the dark green grouping. For the dark green grouping, I have that I'm spanning the A variable, so A drops out. I'm inside of B, I'm inside of C, and I'm inside of D. So that takes care of the green grouping. Now let's do the light green grouping. So for the light green grouping, I am totally inside of A. All right, I'm inside of B. I span the C boundary, so C drops out. And I'm inside of D. So this is the light green grouping. All right, now let's go with the orange grouping, you know, all the 4 corners. All right, so the 4 corners, I'm not in A, I span A. All right, so A drops out. And then I'm not in B. The 4 corners are not inside of B. All right, we span C with the 4 corners, so C drops out. And then we're not inside of D. All right, so that would be the orange grouping that gets the corners. All right. And finally, the pink grouping. All right, so for the pink grouping, we have A, and then we span the B boundary, so B drops out. Then I'm inside of C and outside of D. So this would be the pink grouping. Okay, so you see I have 1, 2, 3, 4, 5, 6 terms to minimize this particular Carnot map. All right, so there's that example.